Hello guys, welcome to the channel. New Apple updates are finally here. The WWDC event was a pre-recorded movie of sorts with fluid drone shots and brilliant cinematography. The event was quick and concise and gave us a whole lot of insight into the upcoming updates for iOS, watchOS, iPadOS and macOS. Let us quickly go through some new key updates for each of them. iOS 14. Widgets can now be added to the home screen and can be placed alongside apps. These widgets can also be placed as a smart stack, where multiple widgets are automatically switched by your device based on the priority at the time of the day. For example, if you have a meeting coming up, the calendar widget is shown, or if you are working out, the fitness widget is visible. The app library classifies your apps automatically and helps you to quickly access apps without the need to scroll between several app pages. Some other features like compact calls, which doesn't take up the entire screen, and picture-in-picture for apps are all new features that have been added. Messages too received small updates. You can now pin chats and reply to a specific message, sort of like a subthread. You can even unlock your car using your iPhone as car keys. There are many more updates to Siri, Maps, Home and Safari. watchOS 7. You might know that Apple Watch is one of the best smartwatches out there with brilliant battery life and its use of a small screen. Now, you can customize watch faces and share them with other users. The Apple Watch now uses its mic to sense the sound of running water and ensures you wash your hands for 20 seconds. It can now track your sleep. It can also track your leg and hand movements through its sensors when dancing so that every calorie burnt is accounted for. iPadOS 14. Apart from most of these features added to iOS 14 which are part of iPadOS 2, there are some extra features now part of iPadOS. iPadOS now supports low power mode, a feature that was already present in older version of iOS. With each update of iPadOS, Apple is trying to bring the iPad closer and closer to macOS in terms of its usage and processing capabilities. The iPadOS sidebar is a perfect example for this. macOS Big Sur. From macOS Catalina to Big Sur, there is a complete new look and design of the UI. The control center volume and brightness sliders are more dynamic. The notification center, Safari, Siri all have a new look and feel. The app icons are now all square and have some shadow effect, which will definitely get some time to get used to. Check out Apple's keynote for all the new features if you haven't already. The biggest news of the day, however, was the announcement of Apple Silicon, Apple's own ARM-based processor for Macs. Apple Silicon, which Apple has been working on for almost 10 years, has finally seen the light of day. Let's see how Apple Silicon Macs compares to Intel-based Macs. Intel-based Macs contain a dedicated CPU and a separate GPU. Some newer Macs include the T2 chip for Apple Pay, Hey Siri and Touch ID. For these Macs, the CPU and GPU have their independent memory. However, on Apple Silicon, it combines both the CPU and GPU on a single SoC or system on chip. This means that it has only one memory, both shared by CPU and GPU related tasks. This increases speed of accessing data as there is no need of copying over a PCIe bus. But do you think this is sufficient for running your more GPU intensive tasks like a physics simulation or a heavy game? Apple has thus dedicated coprocessors for different tasks, video encoders and decoders, neural engine and matrix multiplication machine learning accelerators. One special feature of Apple Silicon is that the chips will have asymmetric cores. This means that tasks that require more processing power can use the more powerful performance cores, while other tasks like browsing or listening to music can be run on power efficient cores. This is called asymmetric multiprocessing or AMP. All cores run all software, but macOS will use all cores simultaneously and applications are scheduled on appropriate cores based on their processing requirements. Now let us see the security aspect of Apple Silicon. Write XOR execute. Write XOR execute means that memory pages cannot be both writable and executable at the same time. Apple has created a new API which enables the quick toggle between writable and executable. This increases the security by changing the permissions of a single thread to be either writable or executable. Kernel integrity protection. This simply means that when the kernel is initialized by being loaded into the memory, it prevents the pages containing kernel code to be modified or other pages to be made executable. So no new code can be added when the kernel is running. Pointer authentication. Pointer authentication is used to prevent the misuse of pointers. Unused bits of a 64-bit pointer are stored with a PAC or a pointer authentication code, which is checked when the pointer is used. Device isolation. On conventional Macs, all devices have shared view of system memory. In Apple Silicon, each device has its own IOMMU, so that each device sees only what it is intended to. Rosetta 1 was used when Apple made the switch from PowerPC to Intel 15 years ago. Now, Rosetta 2 will be used to run software meant for Intel Macs run on Apple Silicon Macs. The apps are translated on install or when an app is launched. Macs running on Apple Silicon now don't have to press a combination of buttons to boot into recovery mode. The startup experience is much better. You can just press and hold the Touch ID button or the power button and it will launch into the startup options. Here you can select and change the startup and recovery settings accordingly. This is inspired from the iOS and iPadOS secure boot mode. Other security features when logging into the Mac or when the Mac is in hibernate mode are also taken care of. Apple Silicon seems very well modeled with every single aspect taken care of. However, what does this mean for the price of Apple Silicon Macs? Apple can very well choose to keep the extra profits or reduce the price for the end user. An Apple Silicon chip can cost up to 10 times cheaper than an Intel processor. The A12Z chip, which powers their new iPad Pro, was used on stage to demonstrate the power of Apple Silicon. The A12Z chip is an 8-core chip running at 2.4 GHz. On a Geekbench 5 test, the A12Z had performance statistics of a single-core performance of 1118 and multi-core performance of 4625. Comparing them to an Intel 4-core i7 10th Gen on the 2020 MacBook Pro 13-inch, we can observe a single-core performance of 1260 and a multi-core performance of 4676. This shows the immense processing capabilities of Apple's chip. However, A12 is not the latest chip in the A series by Apple. A13 in the iPhone 11 and the upcoming A14 will definitely perform much better. In a recent interview, Craig said that even the DTK hardware, which is running on an existing iPad chip that we don't intend to put in a Mac in the future, is just there for the transition, and Mac runs awfully nice on that system. This means that after the 2-year transition period, we will have dedicated Apple Silicon chips meant for the Mac, and it will definitely be very optimized to match with Apple's hardware. Maybe future Macs will have very high computing power with no match to Intel-based PCs. Only time will tell. So that's it for this video. Please be sure to leave a like and subscribe for more tech-related content. See you later.